Hello and welcome to the second lecture of physics of elasticity. ओके एंड प्रीवियस लेक्चर हमने बहुत कुछ कवर किया था यहाँ पे आप देख पा रहे हो इलास्टिसिटी द कॉज ऑफ इलास्टिसिटी द स्ट्रेस स्ट्रेन एंड द वेरियस पार्ट्स ऑफ इट and we discussed the various types of stress and strain. We discussed about shear stress and shear strain and then up to elastic limit. आज हम लोग यहाँ करेंगे क्या हुक्स लॉ. Okay, so let's start without wasting any time. Hooke's law. What it states? It stated that within elastic limit, the stress is directly proportional to the strain. Now you need to be very careful that Hooke's law is obeyed within the elastic limit only. Okay, beyond elastic limit, it does not. The material, the substance does not obey Hooke's law. हम लोग देखेंगे जब हम लोग स्ट्रेस स्ट्रेन कर्व एनालिसिस करेंगे तब हम लोग देखेंगे कि कैसे ग्राफ आपका आता है क्या होता है देन वी विल गेट टू नो अबाउट इट अ लॉट बेटर. ओके, सो हुक्स के अनुसार आपका स्ट्रेस जो होता है आपका स्ट्रेस, लेट मी राइट इट द मैथमेटिकल फॉर्मूला. सो स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू योर स्ट्रेन. ओके, so let me write it in short form. Now stress directly proportional to strain. Now हमें अब क्या करना है, ये proportionality को हटाना है. So we will use a proportionality constant. Let me, I'll write it as S. Okay, stress, मैं stress को S लिख रहा हूँ and I'll give equal sign. Let's write it as capital E. And then ST I'll be writing is a strain as ST. Okay. So stress is equal to some proportionality constant E multiplied by ST. So stress upon आपका जो strain है that is equal to some constant called E. Okay. So according to Hooke's law, basically the ratio of stress upon strain is always a constant E, which is called the modulus of elasticity. This constant has some name which is called modulus of elasticity. Now what we will learn about modulus of elasticity. There are different types of modulus of elasticity and how to use them and their mathematical formulas. अब इनसे क्वेश्चंस आते हैं ज्यादातर. Okay, so let's try to analyze this E. Now what kind of E's are there? There are three types of E's. Okay, so first we will learn about the Young's modulus. Young's modulus. Second, we will learn about the bulk modulus, this is BM. And third, we will learn about shear modulus. Okay, sorry, shear modulus. So these are the three types of moduli of elasticity that we will learn. Okay, let's not waste our time and let's move to Young's modulus of elasticity. So I think Hooke's law is pretty clear to you. बहुत सीधा सीधा बात है कि स्ट्रेस आपका डायरेक्टली प्रोपोर्शनल होगा स्ट्रेन का ओवर द इलास्टिक लिमिट अप टू दैट इलास्टिक लिमिट. बियॉन्ड दैट Hooke's law is not obeyed. Okay, so now Young's modulus of elasticity. Let's analyze this. Let's say you have a rod. Okay, I have drawn the rod in original rod as red color. Okay, so आपका एक रॉड है, इसका ओरिजिनल लेंथ है आपका L. नाउ फॉर एग्जांपल आपने एक लोड यहाँ पे दिया एंड यू आर और यू कैन से यू आर स्ट्रेचिंग दिस रॉड एंड नाउ द चेंज इन लेंथ दैट हैपेंस इज del L. ओके, दिस इज del L and the rod has been stretched up to here, this dotted point. So definitely as you are applying a force, so there is some stress generated and there is some stretching of the rod. और क्योंकि स्ट्रेस जनरेट हो रहा है तो there will be a corresponding strain also. So now let's apply Hooke's law. So Young's modulus of elasticity is denoted as capital Y. Okay, so it's denoted as capital Y. Now let's see how we can analyze this. So we know your modulus of elasticity is stress upon strain. So Young's modulus of elasticity Y is equal to stress upon strain. So what is stress? We all know what is stress. The force you have applied or the load you have given. For example, you can hang a load from that wire or this rod. Okay. So F upon, let's say the area of cross section of this rod is A. So F upon A, and what will be the strain? The strain will be the change in the dimension, the ratio of change in dimension to original dimension. So the change in dimension is del L. So you know this is del L, and the original dimension was L. So this is your Young's modulus. So we can rearrange and write as F into L upon A into del L. So this is very important formula to calculate the Young's modulus. This is the formula of Young's modulus. Okay. And questions are very much asked from this part. Young's modulus. Let me see one thing first. Okay. So Young's modulus is nothing that the force you are applying on the rod or the load that has been given to the rod or where. Now this length, original length, whole divided by area of the cross section of the wire and change in the dimension of the wire or the rod. Okay. This is Young's modulus of elasticity. Now let's come to another very interesting part. You know what? आपको कंपेरेटिव में अगर ये पूछ दिया तो अच्छी बात है, नहीं तो most times in books and sometimes in the competitive exams also you will find questions like this. There is a composite system. For example, आपका ऐसा एक rod है steel का and there is another rod like this which is for example this is steel. Okay, this is steel and this is aluminium. For example, this is aluminium rod. So इस तरह के क्वेश्चंस को आप कैसे सॉल्व करें? I'll just give you a trick. यहाँ पे मैं आपको सिर्फ ट्रिक दूंगा, एक काइंड ऑफ फॉर्मूला मैं आपको दूंगा. When we will solve questions, आपको ये और भी ज्यादा क्लियर होगा. Okay, we'll definitely solve questions on this. I'll make a separate video on questions about the previous year questions that have come in Neet and JEE. So let's see. Just now, you just learned that Young's modulus is the force into length whole divided by the area into the change in the length. Okay, which is del L. And I think ये आप मैकेनिक्स में पढ़ोगे. ओके, आई थिंक नहीं, आप मैकेनिक्स में पढ़ोगे कि हुक्स लॉ स्प्रिंग के लिए जो होता है, इफ यू स्ट्रेच अ स्प्रिंग and it gets stretched by a distance del x or let's say x, so F will be is equal to kx. Okay, where k is the spring constant. K is called the spring constant. Now let's rearrange this F in terms of y. So F is equal to ya del L whole divided by L. So now let's equate these two parts. Okay, ya del L upon L is equal to kx. Okay, now just try to analyze. This del L is your change in the length of the rod or is basically आपका stretched जो change है. Okay, and this x is also your change in the length of the spring. So you can analogously compare these things, right? This del L and del x is kind of same. So by comparing these two parts, मैं कह सकता हूं कि आपका k का वैल्यू will be is equal to ya upon L. Okay, this is very important. This thing is very important because if it is told that आप एक काम करिए कि इसका यंग्स मॉड्यूलस निकालिए, इक्विवेलेंट यंग्स मॉड्यूलस। ओके, सो इन मैकेनिक्स, जो आपको मैकेनिक्स कराएगा, आई लीव इट अप टू हिम, ही विल टीच यू इक्विवेलेंट स्प्रिंग कांस्टेंट for series combination of spring and parallel combination of spring. Okay, and using that concept you can do this type of questions easily. And basically this is in series connection, right? Okay, steel and aluminum are in series connection, so you can find using that concept the Young's equivalent Young's modulus. Okay, this is a very important formula, और ये मैं क्वेश्चन आपको कराऊंगा, इस रिलेटेड क्वेश्चन मैं आपको कराऊंगा, which is very easy actually if you learn these things. So your K equivalent, your K means your spring constant आपका क्या होगा, Y into A upon L, where Y is the Young's modulus, A is the area of cross section of the body and L is the length. Okay, so I think इतना तक आपका clear है. Okay, now let's come to bulk modulus of elasticity. What is bulk modulus of elasticity? I think आप फिगर को समझ पा रहे हो. For example, this is a body, its volume is V. This is a body whose volume is V, and now you are applying normal forces. Okay, यहाँ पे normal force आप दे रहे हो इस area पे, so the body का volume is reduced. Let's say it is being reduced by del V. तो मैं यहाँ पे लिख दे रहा हूँ del V. Okay, it is being reduced by del V. So what is the bulk modulus of elasticity? It is denoted by B, capital B. So again we can say the same way we did with Young's modulus of elasticity, as this is stress upon strain. ये तो Hooke's law, Hooke ने हमें बता के दिया है कि stress upon strain करो. So what is stress? Again we know what stress is, force, and the area you can definitely find out. Okay, you can definitely find out the area, force upon area. And now what will be the strain? Here what is changing? Volume change हो रहा है. So you can easily tell that this is del V upon V. अब एक चीज सुनिए, काफी बुक्स में they use a negative sign here. Why do they use a negative sign here? Because as the volume is being reduced, in the previous Young's modulus में क्या हो रहा था, आपका लेंथ बढ़ रहा था, यहाँ पे वॉल्यूम आपका घट रहा है. So you should use a negative sign, because इसका differential form अगर आप लिखे तो negative sign, as you are using a del, so you can definitely give a negative sign. Okay, now this F minus F upon A, so whole del V upon V. Okay, now B will be is equal to your minus, okay, let's now see, let's do this. Now this force is acting normally to the surface, right? इस बॉडी का जो सरफेस है उसके ऊपर नॉर्मली ये फोर्स एक्ट कर रहा है. सो व्हाट यू हैव लर्नड इन क्लास 9 कि नॉर्मल फोर्स पर यूनिट एरिया इज कॉल्ड प्रेशर, राइट? नॉर्मल फोर्स पर यूनिट एरिया इज कॉल्ड प्रेशर. सो रिप्लेस दिस फोर्स पर यूनिट एरिया एज pressure, and then you write this del V upon V. This is your simple formula of bulk modulus. Okay, I think this is clear up to it. I think आपको तो problem नहीं होना चाहिए इतना तक. Okay, so now let's move on to the next part. Now what happens is that, see, there is another term, okay, which is called K. अब इस K को उसके साथ मत confuse कर लेना. This K is your 1 upon B. Sometimes they ask, JE ask question on this part. K is equal to 1 upon B वाले जो आपका concept है उससे ऊपर question पूछता है. What is K? K is called compressibility. Okay, it's a term which is called compressibility. ठीक है, तो इसको भी आप याद रखिएगा. So this is all about bulk modulus of elasticity. Now let's move to your shear modulus. I think आपको shear strain याद है. मैंने आपको क्या कराया था, shear strain आपको याद होना चाहिए. एक मिनट रुकिए, तो जरूर याद होना चाहिए shear strain कि phi, और मैंने बताया था कि क्यों we are writing tan phi as phi, because the phi angle must be very small. Okay, So you can use that approximation that tan phi is almost equals to phi. So phi will be is equal to your del L upon L. So del L upon L, your phi. So this was your formula for shear strain. So what will be shear modulus? Shear modulus, we write it as G. G will be is equal to, or somewhere it is written as S. Okay, no, nothing important. So G or S is the same. So I'll write it as G, which is, so stress again. I know what is stress. But my mouse is actually is having a problem. Okay, so F upon A, and then whole divided by, so strain is I know phi. Okay, so G will be my is equal to F upon A phi. Clear? So F upon A phi. Again, I know phi is del L upon L. So you can simply write it like, wait, it as that F into L upon A del L. Okay. I don't know why my mouse is not working properly. Okay. So just please bear with it. So this is the formula of shear modulus. I think इतना तक आपको क्लियर हो गया है. So we have discussed about the Hooke's law. Hooke's law क्या है आपका? Stress proportional to strain up to the elastic limit. Then we have discussed about the three different types of moduli. What are those? Young's modulus, bulk modulus, and then shear modulus. All right. So I think it is clear up to this part, and it's very easy. आप समझ सकते हो कि this chapter is very easy chapter. Okay, you should not leave this chapter. Let's move on to the next part, and this is very important. आपके बोर्ड्स एग्जाम, बोर्ड्स तो नहीं मतलब क्लास 11 में रहता है, तो स्कूल लेवल एग्जाम में this question comes, and you can expect this type of questions in Neet also and JE also. This is very important. Let's try to analyze this part. This is called the stress strain curve. Okay, this is called the stress strain curve. For example, there is a wire. मैंने आपको पहले जब बताया था wire है आपका, and you are loading it with some weight. Let's say mg आप weight दे रहे हो, force apply कर रहे हो या फिर कुछ load दे रहे हो इसके ऊपर. Try to analyze what is happening. This O to A, this part. Okay, so I think you can get that this is a straight line. Okay, this is a straight line. So what does a straight line mean? It means that stress upon strain gives us a proportional line. It means that here stress is directly proportional to strain. We have learned na ki stress, which I have denoted by S, will be is equal to your E into strain, which is ST I have denoted in the previous part, ST. So this is an equation of the form your y is equal to mx. Y is equal to mx, right? So this is a straight line passing through origin. So I think it is clear that up to point A, Hooke's law is obeyed. Okay? और अगर आप OA का slope निकाल लेंगे तो you can definitely get Young's modulus of elasticity. Okay? Now this point A is called the proportional limit. इस point A को मैं कहूंगा proportional limit. Okay? This is up to the limit to which the proportion is obeyed. The Hooke's law's proportion law is obeyed. Okay? अब देखो. Now you are adding further weight. For example, you are adding further load. Okay? Now from A to B, Hooke's law is not obeyed. But what is the crux here? आपने और भी लोड किया. Now this graph is going like a curve A to B. It means that Hooke's law is not obeyed here because there is no straight line from A to B. लेकिन आपने मान लो weight को हटा दिया, मतलब deforming force को आपने हटा दिया. What will happen up to B? अगर आपका ग्राफ B तक है, इसको भूल जाओ. यहाँ पे आपका पॉइंट जब B पॉइंट में है, और आपने लोड को हटा दिया, तो क्या होगा आपका? This graph will again retrace back itself. मतलब the body will come back to its original length after you remove the deforming force. So it means it will still have its elastic behavior, though it is not obeying Hooke's law. Okay. So this B point is called the elastic limit. Yes, B point is called the elastic limit. Now beyond B, आपने further load किया, मान लो आपने further load किया beyond B. Now I think you can get from the graph that for a very small increase in stress, there is a huge increase in strain. Okay, ये आप समझ पा रहे हो? So beyond B, this is happening. Actually, this is called plastic flow. Okay, this is called plastic flow. Now what happens? And this is basically the plastic flow में जो होता है, आपको मान लो C में आया आपका. Now you are removing the deforming force. So will it trace the curve back again? No. क्यों? आपने इलास्टिक लिमिट ऑलरेडी रीच कर चुके, आप इलास्टिक लिमिट कर चुके थे. अब क्या हुआ? आप इलास्टिक लिमिट के बियॉन्ड आ गए. So it has already lost its elastic character. Now it will behave as a plastic material. Okay. So what will happen? Now if you are removing the force, it will come like this. It will cover this path. You know? ये आपका एक गैप हो जाएगा यहाँ पे. दिस पार्ट, ये जो आपका पार्ट है जो मैं बोल्ड कर दे रहा हूं, दिस पार्ट इज कॉल्ड परमानेंट सेट. बॉडी इज सेट टू हैव परमानेंट सेट. ओके, इसको आप याद रखिए. अब मान लीजिए आपने फिर से लोड किया, यू आर एडिंग अ ग्रेटर फोर्स. नाउ आफ्टर सी, or you can say beyond C, it reaches point D and there is a fracture, or it's called failure. Okay, so there is a fracture in the body and it will break. The stress, the maximum stress up to at which this body breaks is called breaking stress. Okay, I think इतना तक आपको क्लियर हो गया कि स्ट्रेस स्ट्रेन कर्व क्या है. Okay, A is called my proportional limit up to which Hooke's law is obeyed. A to B, Hooke's law is not obeyed, but the body still possesses its elastic character and it will retrace the curve back to its original length. It means B is the elastic limit. B point is called the elastic limit. Now beyond B, up to B to C, again no Hooke's law is obeyed and it will have a plastic flow. It will behave as a plastic substance. What will happen if you remove the load? Body will traverse this path from C to, let's say this point is E, C to E, and it is set to have a permanent set. Okay, permanent set, ACT set. And then again farther beyond C, the body just breaks. Okay, and the stress, maximum stress at which the body breaks is called the breaking stress. Okay, so this was my stress strain curve. So I think it is clear. Next some important points. This will be the last part of today. I don't know what is okay. We have extension due to self weight, thermal stress, and Poisson's ratio. We have some good important topics coming up in the next lecture as well. So we'll end here today after studying some important points. So this is very important point. There are factual questions that too come in JE and your Neet exam. So you need to be aware of the facts also. कि आपका यंग्स मॉड्यूलस आप लिक्विड या फिर गैस के लिए नहीं अप्लाई कर सकते. इट इज ओनली एप्लीकेबल टू सॉलिड्स. सेकेंड, अ मटेरियल with high Young's modulus is said to be more elastic than a material with low Young's modulus. Okay, and this part is very important, that steel is more elastic than rubber. Okay, so इससे आपको क्या सीख मिलेगा बताइए कि आपका जो मटेरियल है उसका अगर यंग्स मॉड्यूलस ज्यादा हो देन अ डिफरेंट मटेरियल, लेट्स से अ बी मटेरियल, तो ए मटेरियल whose Young's modulus is more will have more elasticity. Okay, so more the Young's modulus, more will be the elasticity. Or experimentally it is found that steel is more elastic than rubber because Young's modulus of steel is much more than rubber. You can search it in the internet also, the values of Young's modulus for steel and rubber. Okay. Next, liquids and gases possesses only bulk modulus. This is also important, that bulk modulus is only possessed by liquids and gases. Okay. Now this thing shear occurs in case of twisting, cutting and tearing. This is an important point. And then for a perfectly rigid body, strain produced will be zero. Why this so-called strain produced will be zero? For example, a rigid body, perfectly rigid body is what, there will be no change in length or any dimension. To be more specific, I should say dimension. There will be no change in dimension. So आपका dimension में अगर कोई change ना हो तो strain zero है आपका, right? Because it is ratio of change in dimension to original dimension. So as there is no change in dimension, so your strain is zero, and we know that modulus of elasticity is stress upon strain. So as strain is zero, so modulus of elasticity will be infinite. So your body will be infinitely elastic. Okay, which is not possible. Real world में ऐसा नहीं होता है. Okay, but you should at least know the theoretical concepts. So आज इतना ही रहने देते हैं. चलो next part देख लो, extension due to self weight, thermal stress, Poisson's ratio, and some important point, and then last will be I think our strain energy, and we'll end this here then, and then after that we'll add some questions and we'll do that. Okay, so next topic will be your extension due to self weight, which we'll do in the next class. Till then, goodbye.